All right, so this is going to be your lesson about the unit circle. So the unit circle is actually a pretty famous topic, I would say. If you were to ask any kids in pre-calculus, they should all know what the unit circle is and be able to identify all the components of it. So the unit circle is a circle that is centered at the origin and has a radius of 1. So we have our equation for the circle, x squared plus y squared is equal to 1, okay? Centered at the origin, radius of 1, okay? Now the values that are contained on the unit circle are very helpful for identifying trigonometric values. But before we do that, we're going to talk about identifying the radians and the degrees around the unit circle, okay? All right, so we start off, and we're going to start off over here, okay? This is actually where you always start your rotations around the unit circle, okay? And so if we have a circle and we start at 0 degrees because we've not rotated at all around the circle, if we were to make a full rotation, however, one full loop around the circle, we would end up and do a 360-degree rotation, okay? But halfway between 0 and 360 would have been 180 degrees. And halfway between 0 degrees and 180 degrees would have been 90 degrees. And halfway between 0 and 90 would have been 45 degrees, okay? And so what you're going to start to notice is the fact that the unit circle is just rotations and parts and pieces of a full circle, okay? So notice that our middle value on each of our quadrants will be 45 increments, okay? So 45 degrees is this value, plus another 45 degrees gets me to 90, and 90 plus 45 would get me to 135 degrees over here. The next one location that we're going to take a look at is if we're at 180 and we continue rotating 45 degrees, that's going to take us to 225 degrees. 225 degrees takes us to our next famous marker of 270, and the last one to take care of is 270 plus 45, which is going to be 315 degrees, okay? Now, but what about these other guys that are looking at the unit circle? Well, this is going to represent a rotation of 30 degrees here, okay? And then if we continue to rotate with an additional 30 degrees, we then work our way up to 60 degrees. Add another 30 degrees and we got our 90. Keep going, 90 plus 30 gets me a rotation of 120 degrees. 120 plus another 30 gets me 150 degrees. And we're going to continue to rotate 30 degrees. 180 plus 30 degrees gets me 210 degrees. Add another 30 degrees, and that gets me 240 degrees. Away from 270, that's going to get me 300 degrees. And then finally, you can look at it this way. We're 30 units away from 360 in the clockwise direction, so we're going to take away, and that gets us 330 degrees. These are all of the degree measurements that you will need to know for your unit circle. But now let's talk about the radian measure. So radian, remember, is going to be in reference to your arc length. And the total arc length of a circle would be your circumference. And the circumference formula is 2 pi times your radius. Well, our radius for the unit circle is 2 pi, and that's why a full rotation, or 360 degrees, gets me a radian equivalent of 2 pi. Just like for 0 degrees, if I've not rotated at all, we have a measure of 0 pi. Now let's continue to think about portions of our pi, portions of our unit circle to fill in our remaining values, okay? Well, half of 360 was 180, so half of 2 pi gets me the radian equivalent for 180 of pi. So halfway around the circle represents pi. Well, half of 180, which would be 90 degrees, and half of pi would be pi over 2. Half of 90 degrees is 45 degrees, and half of pi over 2 would be pi over 4. Okay, so now we're going to use this increment of pi over 4. Okay, so that's this piece of the pie here. Let me color it in a little bit for you. This is the area covered by the 45 degrees, and the the distance around the circle will be a unit of pi over 4. If we continue to rotate by pi over 4 units, well, pi over 4 plus pi over 4 got me to pi over 2. If we add another pi over 4 units, that takes me to 135. So now that's 3 pi over 4, because you would have 3 pieces of your pie. Just chop that a little bit for you. If we add another increment of pi over 4, that takes us to 4 pi over 4, which is what we already have of pi. If we continue to add another increment of pi over 4, we are now at 5 pi over 4, which is the radian equivalent for 225. All right, when we get over to 270, one way of looking at that is 270. Well, that would be 3 rotations of 90 degrees, which is why it would be 3 pi over 2. But if we're sticking with our knowledge of the pi over 4, 5 pi over 4 plus another pi over 4 is 6 pi over 4, which simplifies to 3 pi over 2. So if we're at 6 pi over 4 and we rotate another pi over 4 units, that gets us to 315, which is going to be 7 pi over 4 units. And if we do our full rotation, it's 8 pi over 4, which already simplified to 2 pi. All right, so we're noticing that we're missing some of our radian measures. So we're going to actually start to do our radian measures for 30 degrees, okay? 30 degrees, we're trying to figure out what portion of the whole circle he is. Well, let's just think about what portion 30 degrees is of 180 degrees. Well, 30 times 6 gets me 180. So he is a sixth of 180, and a sixth of pi would get me the radian equivalent of pi over 6. So for every 30-degree pie slice, we're pi over 6. So we're going to add another pi over 6, and we have pi over 6 plus pi over 6, which would be 2 pi over 6, which simplifies to pi over 3. So the 60-degree radian equivalent is pi over 3. If we continue to add units of pi over 6, we're now up to 3 pi over 6, which, like we said, simplifies to pi over 2. We continue rotating. We had 3 pi over 6. Now we have 4 pi over 6, which is going to simplify to 2 pi over 3. So 4 pi over 6 plus another pi over 6 gets me 5 pi over 6. Continue adding, we get 6 pi over 6, which we already have in the form of pi. Add another unit of pi over 6, and now we have 7 pi over 6. We're going to add another unit of pi over 6, and we have 8 pi over 6, which is going to simplify to 4 pi over 3. 8 pi over 6 plus another pi over 6 gets me 9 pi over 6, which we already have as simplified to 3 pi over 2. We're almost there. 9 pi over 6 plus another unit of pi over 6 gets me to 10 pi over 6, which simplifies to 5 pi over 3. Last one, add another unit, so 10 pi over 6 plus another pi over 6. The radian equivalent for 333 degrees is 11 pi over 6. So far, what you have on your unit circle, you have your degrees, as well as what their radian equivalents are. And we've also discussed the fact that all these things are, degrees and radians, are just portions of your circle. Think of it as a cookie or a pie that you are cutting up. All right, so now we're going to look a little bit at some right triangle trigonometry, and then I'm going to connect this and how it's related to our unit circle. So here I have a right triangle. It's a 45, 45, 90. And I know now that my two legs will be the same side length. So let's figure out the exact location given that our exact length given that our hypotenuse is 1. So we have x squared plus x squared is equal to 1 squared. This is going to be our Pythagorean theorem. This simplifies into 2x squared equals 1. Divide both sides by 2, and we get x squared is equal to 1/2. If we take the square root of both sides, we get the square root of 1/2, which will rationalize into being radical 2 over 2. This means that both my side length is radical 2 over 2 and radical 2 over 2. But why are we relearning trigonometry? How is this related to our unit circle? Well, if we look over here at our first quadrant, notice that when we're looking at this 45 degrees, this means that we are 45 degrees away from our x-axis. And the radius of our unit circle is 1. And so this is really just a 45, 45, 90 triangle here. Here is our 45-degree angle, okay? One of the things we need to recognize is 1 is coordinate, and 2, how it's related to cosine and sine. Well, we know that these sides, based upon our problem that we just did, are radical 2 over 2 and radical 2 over 2. So our horizontal translation would be radical 2 over 2, and our vertical translation would also be radical 2 over 2 to get to this coordinate. Notice in the first quadrant we are both positive for our x value and positive for our y value. But how is this relating to sine and cosine? Well, remember our SOHCAHTOA. SOHCAHTOA. Well, the sine of this angle 45 degrees would be the opposite over the hypotenuse, aka your radical 2 over 2, which was your vertical shift. So the y-coordinate is actually going to be the sine of your angle. And the cosine of this angle is the adjacent over the hypotenuse, or your horizontal translation. So what this unit circle is actually able to tell us is all of our values for cosine and sine of our angles. So essentially, a statement that you should now know is the cosine of 45 degrees is equal to the radical 2 over 2. Another statement that you can recognize, the cosine of, well, what was the radian equivalent for 45 degrees? Well, that would be pi over 4. The cosine of pi over 4 is also radical 2 over 2. How is this going to be connected to other angles? Well, let's think about the fact that any angle that is 45 degrees away, so our other angle in the second quadrant was 135 degrees. Both 45 and 135 degrees are 45 degrees away from the x-axis. Notice that these two values are going to share the same y value. And if you recall, our y value is our sine coordinate. The other thing to observe is that in the second quadrant, our x values are negative, which is why you have the statement that cosine is going to be negative in the second quadrant. So we have the coordinate for 135 degrees as negative radical 2 over 2, radical 2 over 2. And once again, just to give us a little bit of reference as to how we use these things, if I say the sine of 135 degrees, sine is the y value, so that would be radical 2 over 2. If I were to ask you for the cosine of 135 degrees, the cosine is the x value, so we would say negative radical 2 over 2. What about other angles who are also 45 degrees away from the x-axis? Well, in the third quadrant, who is 45 degrees away from the x-axis? Well, that would be 225 degrees. If I draw my little right triangle here, he is also 45 degrees away. In the third quadrant, recognize the fact that both your x and your y are negative, which is why our coordinate is negative radical 2 over 2, negative radical 2 over 2. In the context of cosine and sine, what this means is the cosine of 225 degrees is equal to negative radical 2 over 2. This also means that the sine value of 225 degrees is exactly the same thing. Lastly, let's take a look at the fourth quadrant. Who is 45 degrees away from the x-axis? Well, that would be 315 degrees. In the fourth quadrant, this is where your y values are negative, okay? Notice that he is going to share the same x value as our 45-degree angle in the first quadrant. That's why x is the same, or I'm sorry, this is positive, radical 2 over 2, and our y value is going to be negative, okay? So again, if I put a little statement over here on the side, the sine of 315 degrees, sine is going to be our y coordinate, so he's negative radical 2 over 2. Let me zoom out here a little bit here. So far what you should have on your unit circle are the cosine and sine values, aka your coordinates, for what I would like to call your 45-degree buddies. Now that we understand the fact that cosine is our x-coordinate and sine is our y-coordinate, let's think about our pivotal locations that I'm currently labeling right here and here. 0 degrees and 360 degrees share a location. Well, we moved horizontally over 1 unit because that's the distance of the radius, and we did not move vertically at all, 0. So therefore, what this means is the cosine of 0 degrees is equal to 1. The sine of 0 degrees is equal to 0. What about the location for 90 degrees? Well, he did not move horizontally in the slightest, but he moved vertically up 1 unit. What about for 180 degrees? We moved negative 1 to the left and 0 up. And then for 270 degrees, we moved 0 horizontally and down 1 unit. Remember, these coordinates are more than coordinates. They are your cosine and your sine values. So the sine of 270 degrees is equal to negative 1. In a moment, we're going to take a look at the 30-degree buddies, and we're also going to fill in their values. All right, so we're now going to take a look at a triangle that's a 30-60 triangle. So it might be helpful for me to actually redraw this triangle as an equilateral triangle here, because with equilateral triangles, they are all the same side length. And when you draw this line, which is called a perpendicular bisector, it cuts the side in half. So this whole side was 1, making this side a value of 1/2, okay? Well, now I have the ability to figure out what the other side length is of this 30, 60, 90 triangle here through the use of Pythagorean's theorem. So we have x squared plus 1/2 squared is equal to 1 squared. Once again, 1 is my hypotenuse, and that's why I'm able to do this process. So we have x squared plus 1/4 is equal to 1. So we can now have x squared is equal to, if we subtract 1/4 from both sides, 3/4. Take the square root of both sides, so x is equal to the square root of 3 over, well, the square root of 4 is 2. So this is going to be our side length here. But how is this related to what we're talking about with our unit circle? Well, if you didn't know, we can also draw a 30-60 triangle right here, because this angle here of 30 degrees is 30 degrees away from the x-axis. And we know that our radius is 1, and we also know that this side length here is 1/2, okay? And then the side length that we just found had a value of radical 3 over 2. I just wanted to wipe that out. It was kind of bothering me. So for once again looking at the coordinate, our horizontal translation would be radical 3 over 2 to the right, and we got shifted up 1/2 units. Once again, let's think about how this is connected to SOHCAHTOA, sine and cosine here, okay? Oops, let me erase that. Zoom out, go over here. Okay, so 30 degrees is this angle here. We're looking at the sine of 30 degrees. That would be the opposite over the hypotenuse, which is 1/2, which is once again why the y-coordinate is going to be our sine value. If we're looking at the cosine of 30 degrees, that's going to be my adjacent over my hypotenuse, which is why it's going to be radical 3 over 2. So once again, that's just a reminder as to why X is going to be cosine and Y is going to be sine. But now let's think about all the other angles who are also 30 degrees away from the x-axis. For example, 150 degrees. He is 30 degrees away from the x-axis. Notice once again, similar to what we just did on the previous slide, he's going to share the same y value, aka he's going to have the same sine value as 30 degrees. They both went up 1/2 units. Now in the second quadrant, we do have negative x values, aka negative cosine values. So that's why we have the cosine and the sine value for 150 degrees. Now, if we continue, the angle that is 30 degrees away from the x-axis in the third quadrant is 210 degrees. Notice that he shares the same x value as 150, which is radical 3 over 2, but it's negative. And he's also going to have a negative y value of 1/2, once again, because you can draw a 30, 60, 90 triangle. Last angle that's 30 degrees away from the x-axis is in the fourth quadrant, which is 330 degrees. He shares the same x value as in our first quadrant, which is radical 3 over 2, but he's going to have a same y value, aka the same sine coordinate as 210 degrees, which is negative 1/2, okay? Let me just do one more little refresher clarification. So if I were to ask you, let's throw back to radians, the sine of 11 pi over 6. Well, 11 pi over 6 is just 330. Looking for his sine value, aka his y coordinate, which is why our answer would be negative 1/2, okay? Now, if we were to take the triangle that we have, this one right here, and if we were to rotate him, let's see if I can rotate him for you. Kind of like that, except for we want it upside down. That's essentially what we're doing for our 60-degree buddies in our unit circle, which is why the values for 60s and 30s are so similar. They're just going to be reversed. They're just going to be flip-flopped here. So then zoom out, and we're going to zoom in here. So our 60-degree coordinate is actually going to be positive 1/2 radical 3 over 2. So the sine of 60 degrees is equal to radical 3 over 2. Or you could also say the sine of pi over 3 is radical 3 over 2. All right, if we move over into our second quadrant, we're also thinking about who's 120 degrees away from the x-axis, and that would be 120 degrees. Well, the coordinate, aka the cosine and sine value, we have a negative cosine, which is negative 1/2, and a positive sine of radical 3 over 2. Moving into the third quadrant, the degree that is 60 degrees away from our x-axis, that's going to be a total of 240 degrees. He's going to share the same x value as our 120 buddy, and that's going to be negative 1/2. His y coordinate, or his sine value, will be negative radical 3 over 2. Let's just do a little refresher here. Cosine of 240 degrees, that's going to be equal to negative 1/2, okay? Last one, we're almost done with your entire unit circle. So in the fourth quadrant, 300 degrees is 60 degrees away from the x-axis. We have positive cosine values, and he's going to share the same cosine as 60 degrees, but we have negative sine values, okay? Something that I did not point out to you, a little thing that people use to help remember which values are positive and which values are negative where, is the expression that all students take calculus, okay? And what this just means and what this just stands for is that all trigonometric values are positive in the first quadrant. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive, and let's think about why. Tangent is sine over cosine. And so we would have a negative divided by a negative. And then in the fourth quadrant, only cosine is positive, okay? The last step that you're going to need to do is to calculate your tangent values. So I'm actually going to leave that up to you, and I'll leave you with my final words of wisdom. For your tangent, you're just going to take your sine value and you're just going to divide your cosine value. Okay? Sine over cosine, aka take your y value and divide it by your x value. And you may have to rationalize. Good luck!